Alrighty, today we'll be looking at lesson 9.1. And it's going to be talking about the law of sines. All right, so with the law of sines, we use this to help us solve for a triangle's missing side or missing angles, depending on what information is given. So again, a couple of things to just pull out from the section. Law of sine, again, is used when you are solving a triangle, again, for its missing angles and sides, with the information in the form of angle, angle, side. So what that means is you're given, there's a random triangle, but you're given an angle, and a side. And you can also use it to help you find angle, side, angle. So same triangle situation. So that'd be again an angle, a side, and an angle. You can also use this when given side angle. So if you're given a side, and an angle. Right. So if you have triangles in this form here, you will be able to use law of sines to help you find the other missing sides or missing angles. All right, law of sine is basically just a gigantic ratio in the sense that if you take sine of angle A divided by A, that will be equal to sine of angle B divided by B, which will be equal to sine of angle C divided by C. And the way I do this is big letters are your angles. So this is A, B, C, and then the angle of angle A, opposite side would be its side A. Opposite of big angle B would be its lowercase b. This is a capital C, and its opposite side would be a lowercase c. All right, so that's how a triangle is labeled depending on how the triangle looks. But that's ideally what you're dealing with. All righty. When dealing with a side-side angle situation, so given that you have a side, and an angle, there are 4 different types of answers that you can get for just an acute angle. So if this angle that is given is a acute angle, so for acute angles or an acute triangle, um, again, meaning that one of the angles given is less than 90 degrees, you have to find its h. So I'm gonna make a little note here. To find h, you can either do c times sine of a or a times sine of c. Any one of these type of equations, depending on what you're given, will give you your h, which is the height of the triangle. And then you compare your height versus the side that's opposite of the angle you're given. So if we call this a, this would be little a. And then potentially this right here could be, let's say this is angle C, then this would be little c, or this could be B or whatever the concept is. But I would take the C that's given times sine of the angle given. Or if I had this flipped over and this was my A, I could do A times the angle C given. Both of these ratios would give me my height. And again, if this angle A that's given, right, it will be less than 90, then it's an acute triangle. So we compare that A, that's opposite of the angle given, and the H, and if A is less than H, meaning the A side is less than the height, then it can't make a triangle. So there are no triangles, so no answer. If A is actually equal to H, so the A side is equal to the height, there will be one triangle, meaning one set of answers. If the A is between the H and B, the other side doesn't have to necessarily be B, it could be C as well. But if A is between the height and the other side, there's actually two triangles that can be made with that information. And if B is less than or equal to A, you can also have one triangle. So if you didn't even want to look at the H, you could actually go, well, the B, this other angle, is either less than or equal to the given side. So therefore, there's at least one triangle. All right. Now, if you are dealing with an obtuse situation, so for obtuse angles or triangle, however you want to name it, meaning that the angle given is greater than 90, then there are two situations. And this one, you don't have to look at the H. So if A is less than or equal to B, meaning this side is less than or equal to B, there are no triangles. There will be no way to actually make three-sided triangle. If B is less than A, meaning this side would be less than the given A here, there's at least one triangle. Ugh. All right, so that's all that information when using law of sine. It gets interesting in this situation when dealing with a side-side angle. And all this apply only deals with this. If you are given an angle side or angle side angle, it's only one triangle and you can do the math for that and I'll show you. But side-side angle, you do have to go find the H so that you can compare it with the A. But then that's all you do with the H. The H is only to help you determine how many triangles you can make. Other than that, it's not part of the process of actually solving the triangle. All right, at the very end of this, though, it does talk about the area of the triangle. And this is specific to the sine formula. It is given that the area can be written different ways. You can say 1/2 of A times B times sine of C, which is the same thing as 1/2 of B times C times sine of A equals 1/2 times A times C times sine of B. So it could be one of these three equations depending on what two sides and what angle you have. And then you just take the product of that and then half it. And then that would be the area of the triangle. This is one of the ways that you can find the area. In the next section, we'll talk about law of cosine in a different way. All right, so this homework is actually a little bit mixture of just doing some work and then doing some word problems. And I'll kind of do both to give you plenty of examples. All right, we'll start off by looking at number 3. It says solve the remaining angles and sides of the triangle. So you are given that A is equal to 70, B is equal to 50 degrees technically, and little a, meaning the side, is equal to 3. It does not matter how you form a triangle. If you let this be big A, big B, big C, then this would be little a, little b, little c. I do like to draw it out though, to kind of work it out, just so I have the numbers in front of me. Again, how you make your triangle does not have to be to scale. I know this looks like an equilateral triangle, so they'll all be the same, but that's not the point of drawing this triangle. The point is to organize your information. All right, so here I'm given that this right here is 70 degrees. I'm just going to put the 70. We understand that's degrees. This would be 50 degrees. And then my A is equal to 3. When given two angles, we can actually solve for the last missing angle. That is why when you're dealing with law of sine, if it is written as angle side or angle side angle, there's only one triangle because two angles are given. right? What you need to realize is that a triangle's angles have to add up to 180 degrees. So what I would do is I would do 70 plus 50, get 120, and I would take 180 minus 120, and I would get 60. So that means that this right here, this angle is 60, right? So again, you can do that when given two equations. So when I come over here and I am solving for the rest of my stuff, oh, they have it labeled. Okay, just use the letters. So big C will now be 60 degrees. All I have to do now is determine what little b and little c is for the missing sides. And to do that, I can just produce the law of sine ratio. Use what is given. So I'm going to use a sine of 70 degrees divided by 3, and then make a ratio of what you want. I'll start with c, but it doesn't really matter. So this will be sine of 60 divided by c. Right? And you can do the same thing with the b too. Well, we will. So it doesn't matter which one you solve for. You got to solve for both. So we're just going to solve for c on both. So to do that, I'm just going to cross multiply. So that would give me c sine 70 equals 3 sine 60. And then I would divide by sine 70. You will definitely need your calculator when doing this because it actually wants the answer. To say solve the remaining angles. So what I've seen on the homework, it went to about 4 decimal places. So let's go ahead and practice typing that in. And I just need to share my screen because you are still seeing this. Oh, gotta let my thing load. Here we go. Now see, okay. All right, so then here you just simply just type in what you had, which I'm going to be honest with you, I think I forgot it. So I think it was control divide. I'm pretty sure it was 3 trig sine. Oh man, you know what? I think I messed up too. This is one downfall, not being in the classroom with y'all. I think I started looking at number one. So 70, 50. The only change here needs to be this B. It was given that the B was equal to 4. So I need to change. I don't know my A, and I actually do know my B. My B is 4. So therefore, I can't use this ratio because that's not the ratio I was given. So this would be sine of 50 over 4. And again, I'm actually looking for A and C. My bad on that one. And so again, but the process doesn't change. It doesn't matter which ratio you go with. Again, this would be sine of 60 over C. And when I cross multiply, I would still get C sine. Ooh, I don't know why I wrote S twice. C sine 50 equals 4 sine 60. Divide by sine 50. So this would be sine equals 4 sine 60 over, I totally forgot the whole rest of the sign, sine 50. All right, but this is the part that you would type in. So let me go back to the calculator. Let me, hold on, before I do that. 4 sine 60, 50, okay. 4, 60, 50. All right, so it was actually 4. I think it said 50, 60. Hold on. And this will, again, this will actually be, uh, trig sine 60. All right, make sure I got that right. 4 60 50. I don't feel like I did. 4 60 50. Okay, let's get this flipped. It'll be a lot easier for you because you'll be able to see the paper at the same time. I cannot. All right, so then you just get your answer there. So for I think we just solved for C. We would just go 4.5221 on the homework. All right, so again, we just calculated for our C. So again, that would be 4.5221. And that would be the answer. And then you would do the same process again, but now for the A. So this would be again sine 50 over 4. And then equals, so sine 50 over 4. And then we just need A. So that would be then sine 70 over A. And then same process, cross multiply and divide. So this would be A sine 50 equals 4 sine 70. If you see the pattern here, you can go straight to that as well. Don't have to show this process. But until you see it, I'll keep showing it for you. All right, I'm actually not going to flip back to the calculator, so hopefully you're able to remember how to do it. If not, please let me know. But I will type it in so that I can keep an eye on it. So again, just do control divide, and then for your trig function of sine 70 divided by trig function of sine 50. And on this one, we actually get 4.9067. The 3 would tell the 7 to stay the same. All right, so again, that's really all you're doing pretty much on this entire practice is just given different situations. All right, so let's do different situations so that you have the different situations. Let's look at number 9. This time it says create a triangle if possible using the given information of law and sines. So this is where it's going to get a little interesting for us because we're going to be given one angle and one side. So we'll be dealing with side angle. All right, so here we go. So on number 9, we have angle is equal to 40 degrees. A is equal to 2 and B is equal to 4. Again, I like to produce my triangle to make sure I truly do have a side angle situation. So here's my A, here's my B, here's my C. So this will be little a, little b, little c. I'm given that A is 40. I'll use a different color. I see that my A is equal to 2 and my B is equal to 4. So this is again given to me as side angle. So this does fall into this category. Now we just need to determine my H. So this will be your first step. Remember H is given as C times sine of A or A sine of C. So we actually have I do not have a C. So I can't even calculate it. Let's see, hold on. So let me backtrack to make sure there's not another formula where I tell you that this would not be possible because I'm missing something. That's all we have. C sine A sine C. Yeah. All right, so in this situation, I do not have the right letters to be able to calculate my H. There's no, yep, okay. So therefore, this right, no triangle made. So you can't compare the H if you don't even have the ability to calculate H. So number 9, no triangle. All right, let's look at number 10. Number 10 is given to you as excuse me, A equals 40 degrees. A equals 4 and B equals 4. All right, so again, this is just for labeling purposes. So A, B, C. So this would be A, B, C. So this will be 40 here. This will be 4, and this would be 4. Again, this would be a side-side angle situation. And again, to calculate the H, I think I'm gonna be in the same situation. H again is given as either C sine of A or A sine of C. And I'm given nothing about C. But I'm almost positive they both can't be. Let's backtrack a little bit. Let's look at this ratio, this C times sine of A, or this A times sine of C. So this side times this angle, or A times sine of C. No, there's got to be a different way about this. Hold on, let's look back. All right, so if we look back at example 3 in the book, we were given an AAB. They were able to solve it. They did B sine A. Okay. So they need to show that a little bit better. So, okay, so it's really just a side times an angle, side times an angle adjacent to it. So we could also say then that this would be equal then to B sine A as well, because that's exactly what they did to calculate their H. They took their B times sine of A. So that's what we'll also apply as well. So let's, before we can clear this one, we would then do 4 times sine of 40. So let's calculate that real quick in our calculators. So that would be 4 sine 40, and that would give me 2.57115. I'll take the whole number that it gives me. And then according to our information, we need to compare it to our A. So if this is my H, my A was 2. So if, where we at? So if A is less than H, so 2 is, so if A is less than H, there is no triangle. So it's still a no triangle here, but for our situation over here, we can add in that B times sine A as well. And so when we calculate our H, we will do 4 times sine of 40. Oh, wow. We just did that. I like that. Did I use the right numbers? I did. Okay, cool. All right. So we already know that this answer here is actually 2.57115. And this time my A is 4. So in this situation, if A is greater than B, it can either have one or two answers, but now I got to compare it to my B. So my B was 4. So for it to have two answers, to have two triangles, in this situation, H has to be less than A, less than B. Well, A is greater than H, but is not less than B. It's actually equal to. So if A is greater than or equal to 4, which in this case it is equal to, it will have one triangle. So there's only one triangle. So using those charts that kind of help us figure out how many answers we're going to have is going to be key. And the more we do this, the better we'll get at it as well. All right, so since I know that I have one answer, I just need to kind of determine how I want to play this out. I will start with what I know to produce a ratio. So I know sine 40 over 4, and then just solve for any missing. I'll start with B. So sine B over 4. To solve this one, I would, yes, technically, you can do the old cross multiplication still. So this would be 4 sine 40 equals 4 sine B. In reality, I'm just going to do hypothetical here. If this sides are the same, these angles should be the same, but I wanted to show you that law of sine will give us that. If you are dealing with a triangle that has the same side, the angles must be equal as well. But let's prove that since we have that ability right now. So we'll divide both of them by 4. So now I get sine 40 equals sine B. So now what I'll do is I'll do the sine inverse of both sides. This will be left with my angle. But you'll see in your calculator, and I'll show this part here. So let me screen share. So if I do sine inverse of sine 40, again, we're in degree, you actually get 40 right back out. So, and that again should make sense. If both sides are equal, then both angles would have to be equal. So now I know that angle B is 40 degrees. And if you have two of them, then you can solve for the last one. So 40 plus 40 is 80 minus 180. This tells me angle C is now 100 degrees. So now I have that. And with that, I can now produce a ratio. So I now have, and I'm going to use, you could use either one of your findings. I'm going to stick with what was given. So sine 40 over 4, and really and truly, you don't know if I'm using A or B right now anyways. And then this will be sine 100 over C. I did use A because I like to use what is given, but technically once you solve for some of these things, you can use them as well. Just watch out if you end up with decimals because then you could have a rounding error. So always stick with what is given. All right, so with this, I want to multiply both sides, or cross multiply, sorry. So this would be sine of, sorry, C sine 40 equals 4 sine 100. Divide both sides by sine 40. So this right here would be 4 sine 100 equals C. So again, I'll jump back to my calculator, doing controlled divide. It'll be 4 sine 100 divided by sine 40. And on this one, I would get my little c is equal then to 6.1284 because the 6 would make you round up. All right, so good. I'm glad we cleared up this piece right here to give us many different answers for our h that we're able to properly calculate it. And they should have added that in the book. All right, let's look at other cases though. Let's look at number 15. So if B equals 80 degrees, A equals 2, and B equals 6. All right. Again, this is a side angle situation, but graph it out. So again, this would be my A, B, C. So this would be my A, B, C. I'm given 80 here. I'm given 2 here, and I'm given 6 here. So this is, no matter how you write it, it's still going to be side angle. Ooh, we don't have angle side. So definitely write it the correct way. All right, so now we just got to calculate our H. Given the formulas that we have produced up to this point, we have C sine A. I don't have a C. We have A sine C. I don't have a C. And then we also just discovered B sine A. Right? I don't have that as well, right? I don't have that sine A. But keeping up with this pattern, I could probably also write this as C sine B. So again, it's just the side and an angle next to each other. I could have probably even gone one step further and actually said this is A sine B as well. So you can see all the different type of ratios that we could do to solve. So really, again, it just comes down to taking a side and the angle next to it and just multiplying it out. So this will just be H equals 2 times sine of 80. And let's see what that gives us. So again, 2 sine 80, and we get a 1.96962. Again, I'm going to keep the whole number so I can round appropriately. We are dealing with a side angle. We're dealing with an acute angle. So we have our 4 different options. First option is A less than H. So is 2 less than 1.969? And it is not. So we definitely don't have no triangle. Is 2 equal to 1.96962? You could if you round it, but we don't round. So therefore, there's not one triangle. So it is A equal H. And then the next one is A between H and B? Well, A is in fact greater than H, and it is less than B. Therefore, the other one is A greater than or equal to? A is not greater than or equal to B. So in this case, I'm seeing that there are 2 triangles to make because the A is greater than H and less than B. But my worry here is that A, let's look at our previous 2. I was given my A with angle A, and I was given my A with angle A. I think that A is actually the side that is opposite of the angle given. So let's look back at our examples. We're dealing with side angle sine. So we were given, let's see. So we were given ABA, and we used B sine A to get our H. And we compared our A to our B. I'd love to see a different example. And you were given ABA as well in example 4. Yeah, so let's make that a new rule. We're not actually comparing, just like in this H here, we're focused on all these different situations. It's always going to be the side and the angle. The side that we're actually really comparing when we say compare A to H and stuff like that, H again is represented by whatever the side times the angle is. So in this case, this was A times sine of B, which would be this guy right here. Um, and then the actual A will be whatever the side opposite of the known angle. So in reality, I'm actually comparing my B to my H. So is 6 less than 1.9692? It is not. Is my B equal to my H? Again, it is not. So that means is H less than my B less than my other known psi, which in this case is A. So B is in fact greater than H, but it's not less than A. So there is not two triangles. And then so is my, I know on the note it's B less than or equal to A, but really is it A less than or equal to B? So in this case, 2 is less than or equal to 6. There is only one triangle. So definitely the what we're looking at with our equation is that was really stuff that was given if you were given the angle A. So I wish they would have kind of explained that a little bit more. But we figured that part out, so we have that information now. So we are again comparing the side. The side. So the side that's opposite the angle given is the A that's in our formula. And then the B is the other known side that you're comparing it to, right? In this case, we had to kind of switch all of our A's and B's opposite of each other. All right, so but even though now we know that there's one triangle that we are looking for, we can now move on to the actual math. So a lot of pre-work with law of sine, not so much with law of cosine. And we'll talk about that in the next video. All right. Anyway, so we'll use what information we're given. So this will be sine of 80 over 6 equals any other ratio you need. I'm going to do sine of A over 2. This time they should not equal the same angle like last time. So we'll cross multiply. So this would be 2 sine 80 equals 6 sine A. And then we will divide by 6. So we get sine 80 divided by 3 equals sine A. And just like last time, I'll take the inverse of sine of this given answer. So again, I'll switch back over 80 and 3, 80 and 3. Hopefully I don't forget that. But just so you're able to see this and make sure you are seeing this. All right, cool. So this will just be trig sine inverse. I'll do control divide. And then I'll do trig sine 80 and then 3. And there we go. So we get a answer for our angle of about 19. And again, on the homework, I saw them go to 4 decimal places. So for this one, our first answer, I'll write it over here. Angle A is 19.1638 degrees. All right. And so then all I got to do now is find the missing angle C. So what I'll do is I'll take this 19. So I'll take that 19 point whatever, and I'll add it to 80. And then I'll do 180 minus that answer. So that was going to be 99.1638. Subtract that answer. And we get for our missing angle C, 80.8362. Okay? So almost the same. And now, once we have that, now we're able to actually produce the ratio. But this is, again, where it's important to use what you have, so there's no rounding errors. I'm going to use sine 80 over 6 equals, I am going to have to use this rounded answer over C. But it's better to then having to do sine of 19 point this over 2 equals sine of this over C, because then there's 2 rounded answers. And it might not be rounded. Maybe it came out perfect. I doubt it, but maybe it did. But that would be kind of how to best avoid rounding errors. So now I'll just cross multiply. So this is C sine of 80 equals 6 sine of 80.8362. Divide by sine 80. Divide by sine 80. And this would give me, let's look at that. So this would be control divide 6 trig sine 80.8362 divided by trig sine of 80. And we get about 6.0148. And there's the rest of your missing parts on 15. All right, so now that we have a little bit more understanding of what the A and the B and the H really represent, and not just the letters that were given to us, let's look at number 16. Number 16 is B equals 50 degrees, B is equal to 2, and C is equal to 5. So when I produce my triangle, and just labeling purposes, my B is 50, my little b is 2, and my C is 5. So when I produce my H, I'm not even going to use the formulas. I know it's just going to be the sine times the angle. So this is going to be 5 times sine of 50. So let's figure this out. So this would be 5 trig sine of 50. And I get 3.83022. Again, not rounding because I'm comparing, so it's not giving me the answer quite yet. All right, now when I'm comparing my number, I'm really comparing my B to my H. So when I write this out, I want to ask myself, is B less than H? So is 2 less than 3.8302? And the answer is yes. So therefore, there is no triangle. Right. So now that we know exactly which numbers we're really comparing, and not just so much the formulas that they gave us, we can get to the answer a lot quicker without hesitation. Right. So I want to make sure you solve that with a better clearing. Let's look at a different type of situation because we haven't dealt with an angle C yet. So let's look at number 27. C equals 116 degrees. This is actually an obtuse situation because this is greater than 90. So do pay attention to that. All the H stuff only has to be done when it's less than 90. When it's greater than 90, you're really just comparing your two known sides. So you have 116 degrees. A is equal to 24.1 and C is equal to 25. Again, when I label this, it is for labeling purposes. I'm not drawing this to scale. So I am told that this is 116, this is 24.1, and this is 25. So definitely a side-side angle situation. And again, we are just going to be comparing our A and our B. And with an obtuse, you either have no triangle or one triangle. But again, in the notes, it states, we're comparing A and B. Well, we don't even have a B. What you're comparing is the A, is it, the side opposite the angle, is it less than B? So in this case, we are looking more as, is C less than or equal to A? So the A in the formula is really the side that is opposite of the known angle, and the B is the other side. So in this case, I'm really asking myself, is C less than or equal to A? So is 25 less than 24.1? No, it is not. So the other case is A less than C? And in this case, yes, 24.1 is less than 25. That's the only two options you can have. So we do know we have at least one triangle to look for. All right, so knowing where those letters come from definitely make it have more sense. All right, after that point, now that you really know you're looking for some answers, let's pull it up. So we have sine of 116 over 25. Again, my known information equal to my other known. So this will be sine A equals 24.1. Cross multiply. So I get 24.1 sine of 116 equals 25 sine A. I'll then divide by 25. Again, if you identify the pattern, I am good with this. You're getting straight to this point. So 24.1 sine of 116 over 25 equals sine A. And just like before, to get rid of that sine, I'm going to take the sine inverse of this answer. So I think we've seen that enough times. I'm not going to pull it up. So this will be sine inverse, control divide, 24.1 times trig. So that's sine of 116 over 25. So for my angle A, I have 60.0473. This will be my degrees. And then now that I have that, I can add that to, oops, sorry. I can add that to 116 and then take 180 minus that answer. And I actually get 3.9528 degrees. Because again, it's going to have that 5 is going to round up. So it makes a triangle, but it barely makes a triangle, but still a triangle in itself. All right, so there's my missing angles. All I got to do now is go find my missing side. So this will now be sine of 116 over 25. Again, I want to use that nice, clean given information equals now sine of 3.9528 divided by b. So we do some cross multiplication. This will be b sine 116 equals 25 sine of 3.9528. And then we'll divide by sine 116. So b would equal whatever that is. So let's do that. So that would be control divide 25 sine 3.9528 divided by trig sine 116. And I get approximately 1.9174. All right, and there you go. So that's all the different type of situations that you could have. We saw a pretty easy one given two angles and a side. Those are the easiest ones to do. You don't have to stress about how many triangles there are. We dealt with all the different type of side angle ones where you have to what you have to kind of figure out. So now let's get into finding a area. So let's jump to number 31. So it says find the area of a triangle given the information. So we have A equals 131 degrees, B equals 10, and C equals 25. All right. Now, when it comes to finding the area, I'm not really stressing. Well, maybe I should. Let's look at the area formula. What's the? Yeah, when I'm coming up with the area, I don't need to solve the triangle. The area of a using law of sine for a triangle is 1/2 AB sine C, or 1/2 BC sine A, or 1/2 AC sine B. And in this case, I have the BC and the sine, so I will be using this one. So again, don't have to solve the whole triangle. You just got to plug it into the formula appropriately. So this becomes 1/2 times 10 times 25 times sine of 131. One thing to note, and I don't think I illustrated this, we've been dealing with degrees this entire time. So make sure your calculator is in degrees, because if your calculator is in radians, you're going to get some unrealistic answers. So do make sure and note that. So again, I'm just going to type actually I'm going to just do 0.5 in the calculator to make it easy, but you can write 1/2 if you like. I'm going to do 0.5 times 10 times 25 times sine of 131. Then I get, again, I saw on the homework, I made a note of this. They round it to the hundredths place. So in this case, this would be 94.34 as your area. And that's it. Now, that's pretty much as straightforward as it can be. However, though, there is one question in there that they tried to make an area formula complicated. So I want to go over that one as well. So they give you number 32. It says B equals 60 degrees and 7 minutes. And C equals 18 and A equals 6. All right, so what they did here is they put it in degree, minutes, seconds. So you have to convert that back into degrees. And recall to do that, so again, degrees, minutes, seconds, to put it back in degrees would just be 60 plus whatever this number is divided by 60. Had there been seconds, it would be that number divided by 3,600. And then you would just add up the fraction. So I'm going to do that over here in my calculator. I'm going to do 60 plus control divide 7 over 60. I'm going to add a decimal in the calculator so I get a decimal out of it. And I actually get 60.1167. So I use that information, and now I'm going to calculate my answer. So remember, it's just going to be 1/2 for the area times the given sides. So you don't even need to know the formula. You just got to know how the process of the formula works. So it's going to be 18 times 6 times sine of 60.1167. So again, they do try to, in the homework, take something that can be so simple and try to make it more complicated. So 0.5 times 18 times 6 times sine of 60.1167. So my area here would be 46.82. Okay. So watch out when you see that one. And then let's just do one more to make sure you got it. I'm just going to do number 34 right below it. And we have B is equal to 54 degrees, A is equal to 10, and C is equal to 7. So one more time, the area here would be 1/2 times 10 times 7 times sine. I guess I put it in parentheses. 54 degrees. All right. If we come over here, in 0.5 times 10 times 7 times sine of 54, and I get 28.32. So again, that should be enough on the area of a triangle. So let's get into what you might struggle more with, but hopefully you end up finding them to be relatively straightforward, is those pesky word problems. All right, so let's look at number 39. All right, number 39 says Jack wants to build a tree house. His parents worry that he is building it too high. If Jack's dad is looking at the tree house, okay, so just build some things. Here's what I call a tree, and I will put a house in it. All right, this is what I call a tree house. All right, and it says if Jack's dad is looking at the tree house location from a 70-degree angle, so here's Jack's dad looking at it with a 70-degree angle. and then moves back 10 feet. It moves back 10 feet so we can see it at a 50-degree angle. So now Jack's dad is at a 50-degree angle. How high is the tree house location? So we moved back, right? Okay. All right. So in this situation, we are, how high? So we're looking for this guy right here. All right. So that's our mystery. Um, so if we know this is 10 and this is X, then really and truly, this right here would be 10 plus X. If I needed to know it, this would be my Y because I don't know that one. So how could we produce a trig function here? So I see I need to know sine of 50. Actually, you know what? If he's looking at it, this right here has to be 90, which then tells me that this angle for this big guy here, um, 50 plus 90 is 140 will be 40 degrees. All right, so this is 40. Let's make that clear, and we'll do a different color as well. This is 40 degrees. Still think that's not easy for you to read. 40. If I look at the big triangle. So I can kind of say, all right, this is sine of 40 of this, but I'm gonna have to use this part here. So this would be 90. This will be 40 here as well. And this would be so 50, 90, 40. That gives me 180. I have to somehow know one of these sides. So Jack wants to build a treehouse. His parents worry that he's building it way too high. Jack's dad is looking at the treehouse location from a 70-degree angle and then moves back 10 feet so he can see at a 50-degree angle. How high is the tree? Man, all right. So, yeah. So we have, if we even look here, this would be 40. If we look at this triangle alone, I have too many variables. This one, the only thing I could solve for is this, how tall he is. I could solve how tall Jack's dad is with just this information. Um, then that wouldn't help me determine how tall this guy is. Given that this is 10 feet back. Let's look back in the book. Let's see if there's anything good in there. I don't think I did see any word problems in the book. All right, so let me tell you. Oh, here we go. So it says Sarah's piloting, blah, blah, blah. Directly along the road, she notices the marker of 1 mile. Determines the angle. Far is the marker. All right, so I'll tell you what, I'm actually gonna stop this recording, look at what the best approach of these problems are, and then share those findings with you so you don't have to sit here and wait for me to find the best approach. All right. Again, I'll continue this video in the next one. Until next time.